Right. So for the first one, given a 90% confidence interval of 45 and 105 for a mean heart rate, which of the following is the best interpretation of this confidence interval? We are 90% confident that the true mean heart rate is between 45 and 105. There's a 95% chance. 90% of all people have a heart rate, and there's a 90% chance. Isn't the first one?
Yeah, that's what I think it is.
Yeah, I'm almost positive it'd be the first one. Alright, we gotta go pretty quick, so you can get out of here, Kelly, so you can go to Payson.
Yeah, that's gonna be fun.
I just got some pepper down my throat. Oh gosh.
Topic number 3.
Recently, some water.
The University of Mississippi wanted to determine whether the reaction time in seconds to go, no-go stimulus of males differed from that of females. Researchers randomly selected 20 females and 15 males to participate. The go, no-go stimulus required the students to respond to a particular stimulus and not to respond to other stimuli. The researcher decided to construct a confidence interval to determine if the difference of the means is significant. To determine whether the confidence interval would be reliable, they create QQ plots of both random samples and see that they are approximately normal. Are the requirements of constructing a confidence interval satisfied? Why do I not?
Let's see here. So just got here, so we have another person to help us.
I emailed my teacher and told him that I'm
today.
Okay.
I was like, I cannot afford that.
Yeah. Have you started on it yet?
I have 5 properties.
Okay. So we're on number 3. For number 2 we put the first option. Number 3. Something about a QQ plot.
Well, I'm going to say it's B.
You might need to connect to the Wi-Fi. So it is it 5 or 2 the better ones, sir? Sir, is 5 or 2 the better one? For Wi-Fi, NH2 or NH5? NH2.
Here's your Red Bull.
Thanks. Okay, so we're going with the second one you said?
I think it's right, because if you have 35 people, it's not really distinct between men and women, even though it starts off that way.
Okay. And then for number 4.
The 4 types of confidence intervals listed below, which one is appropriate for the experiment?
And then the last 3 months I would clear up here where like superior is it?
Confidence interval from you when standard deviation is unknown. Yeah, I think it's the second one.
Long hair, frisky. Yeah.
Yeah, second one makes sense.
That's cool. Yeah.
Number 5, a researcher is interested in estimating the savings account balance of customers at a large bank. She obtains the savings account balance of a random sample of 30 customers. A 95% confidence interval for the mean savings account balance of bank customers is found to be $3,402.08, and then also $4,142.75. Which of the following would produce a confidence interval with a smaller margin of error than this 95% confidence interval?
That's super cool. Well, I guess we'll get started. Yeah. I want to take up here and talk about it. Do you want to take it up in breakfast? Sure. Yeah. And it's Nicole and Lena. It's okay.
What number are we on?
Number 5.
Number 5?
Yeah.
It's the factory one, right?
Oh wait,
Oh, wait,
Josh
you guys
is
are
on.
you guys
Oh,
are
wait.
on the actual quiz already.
I didn't even recognize that voice. I was like, who is that?
Yeah, I was a
Sorry,
little
guys.
confused.
This is Josh. I'm the new one.
Hey,
Oh,
what's up, Josh?
You guys
Welcome.
are already on the group meeting, right?
Yes, we're recording.
Yeah.
But you've started the quiz.
Yeah, we're on 5.
Okay.
You can review what we have to.
So yeah, we already did 1 through
5.
4, and we're on number 5 now.
Okay.
I think it might have something to do with the sample.
yeah, I think
So,
it is. It's either A or B.
so for number 5, I put B.
Okay.
As n increases, then your margin of or your interval becomes it's closer. Your interval gets smaller. I
He's saying
think.
that when your n increases, your interval goes smaller. So it would be B. Yeah. Yeah, it's B.
Okay.
All right, number 6. Who wants to read it?
I'll go ahead. Okay, a factory makes propeller drive shafts for ships. A quality assurance engineer at the factory needs to estimate the true mean length of the shafts. She randomly selects 4 drive shafts made at the factory, measures their lengths, and finds their sample mean to be 1,000 millimeters. The lengths are known to follow a normal distribution. Standard deviation is 2 millimeters. Calculate a 95% confidence interval. So for this one, I got A. After I did the confidence interval equation, 998.040 and 1001.960.
We all know that marriage
Let's see.
God knows.
Still weird. So I have a friend here as well that she wasn't able to meet with her group because they're being down.
They suck.
So
Literally 5 minutes
So-
before we were supposed to meet, they
you
canceled.
thought it was A.
Yeah, I got A. What did you guys get?
So we're opening this for the first time, like as a group.
Oh, are you? Oh, okay. Cool.
Did you already finish this?
Yeah.
That's
Oh.
fantastic.
I haven't done the quiz though. So what you do is there's the confidence interval like equation. You take the mean of the sample minus the z-score times the standard deviation divided by the square root of n
Right.
for the first part, and then the second you add it to the sample mean.
You're up or down and lower.
Yeah, you just take the negative and the positive.
And so A is the one that is the values that you got.
That's what I got, but maybe someone should work it out and see. Maybe I got it wrong.
Sometimes the world,
Let me see.
sometimes the world, tell us how we should, or tell us that we're this and that. And they're I love them to death, but they're just, my testimony from what I read from this is that marriage is no matter what.
Yeah, it makes sense that it would be the first one just from looking at the other options because your standard deviation is only 2 millimeters off of 1,000 millimeters.
So it has to be less than 2.
Yeah, it makes sense.
That does make sense.
The only other option is C.
Hey, can you read off that?
A and C are the only 2 that they could be.
Let's go. I say we just go with A on 6.
Yeah, I agree with A.
And then number 7.
To assess the accuracy of the laboratory scale, the standard weight is known to weigh 1 gram. It's repeatedly weighed. Total of n times, and the mean of the weights is computed. Suppose the scale readings are normally distributed with unknown mean and standard deviation of 0.01 grams. How large should n be so that the 95% confidence interval for mu has a margin of error of plus or minus 0.001?
There's like a,
So Josh, didn't you say that like the larger the sample size, the smaller the standard deviation, or like?
Yes.
Right. Exactly. So for this one, there is an equation to find n, or sample size. And the equation that I used is z times standard deviation over m, which m is the margin of error, and then you square all of that. The answer I got was C, 38,416. So I can't remember what lesson that equation's from.
We're looking at it right now.
Okay, cool.
It's
it's
in
from lesson 10.
lesson 10.
Lesson 10, okay.
Yeah, n equals z times the standard deviation divided by m, all to the power.
And then you square it.
Yeah.
So the z-score for 95% interval is, I think, 1.96?
Yes, it is.
Okay.
Yeah.
So
So yeah, that's what you get is 38.416.
Yep.
awesome.
Sweet. Josh, you were being very helpful so far.
Hey, I gotta make a good impression, right?
All right, number 8. Jess, do you want to read it?
What?
Do you want to read it?
Okay. No, you read it. This is your
It's your turn.
group. This is your group.
The mean area mu of the several thousand apartments in a new development is advertised to be 1250 square feet. A tenant group thinks that the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to test their suspicion. The appropriate null and alternative hypothesis are as follows.
It'll be A, right? We're assuming that they're less than 1250, and they I think it's A.
So A? Is that what you got, Josh?
I agree with A.
Sweet. Whose turn is it?
I can read. In a statistical test of hypotheses, we say that data are statistically significant at the level of significance alpha if
P-value is less than A, B.
That's what I got.
less than alpha. Okay.
Second option.
Very obvious. Yeah.
P-value is less than A. Alright, number 10.
Is it my turn? Oh, I don't care. A group of statistics students want to determine if students in some apartment buildings get a better grade than other students in other apartment buildings. They collect GPAs from a anonymous group. Sample size of 15 from each of the 4 different apartment buildings. The data from each apartment buildings are bell-shaped with no outliers, and sample variances are nearly equal. Can they use an ANOVA hypothesis test to answer the question? Their question.
Yeah.
I think I got A. So because the two requirements are that they have to be normally distributed and the sample variances have to be equal.
Not that it has to be more than 30.
Yeah.
Okay.
What do you guys
that'd
think?
be- Yep.
So they
I concur.
Cool.
catch me if you can.
Okay, I'll read 11 then. I haven't read one in a minute. So it says a medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis for the standard treatment is 2 years. So the null hypothesis is that average survival time after diagnosis is the same for the new treatment and the standard treatment. In an early trial, she tries the new treatment on 3 subjects who have an average survival time after diagnosis of 4.5 years. Even though the sample is small, the results are statistically significant at the 0.05 significance level. Consequently, she rejects the null hypothesis. In a future study, it's determined that the new treatment does not increase the mean survival time in the population of all patients with this particular type of cancer. Which error has she committed?
It's type 1.
Hey, reject the truth, right? Type 1.
Yep.
Wow, guys, good memory.
Nice.
Well,
Do you agree with that? Okay.
Oh, yeah, I thought we were good on that.
All right.
Type 1 for 11. Number 12, if the level of significance A is very small, thereby making the probability of committing a type 1 error very small, what happens to the probability of committing a type 2 error?
goes up.
Yeah, look up what type 2 is again.
This is like chapter 8 or 9.
I know that they're opposites. If your
Yeah.
type 1 is small, your type 2 goes up. I remember that.
He's right. I think it's D.
Type 2 is when we reject a null hypothesis.
A
Yeah.
little
Yeah.
bit. Not like, so like, I don't know what.
Well, you know, it's not B and C, so it's either A and D. I'm just thinking about
Guys, just for heads up, like the order of our questions might be different.
Oh.
I don't think it is.
I don't think they are.
Sometimes it is. I agree that we should read that.
So
Okay.
I think it's by reducing the probability of committing type 1 error, we increase the probability of committing a type 2 error.
I agree.
I agree with that.
That's D for me. I don't know for you guys.
Wait.
Yeah, it's D.
So
Oh, you said increase, I thought.
by reducing
It's the same.
the probability of committing a type 1 error, we increase.
Yes.
Increase. Yes.
Okay.
Those are opposites.
All right. I'll read this one. The nicotine content in cigarettes is certain brand is normally distributed with mean in milligrams mu, and a known standard deviation of that omega. Was that omega? I can't remember that symbol. Equals 0.17. The brand advertises that the mean nicotine content of cigarettes is 1.5, but measurements on a random sample of 100 cigarettes of this brand give a sample mean of X bar equals 1.53. Is this evidence that the mean nicotine content is actually higher than advertised? To answer this, test the hypothesis.
At 5% level of significance.
So, for reference purposes for the level of significance, I found the p-value and compared it to that. I don't know what your guys' thought process was or is on this one, but
Yeah, you have to find p-value, right, to
I
compare
found
it.
the p-value, and then from there you can decide whether to reject or fail to reject.
Yeah.
Yeah, that's
So
what we
I
can
just found the z-score and then plugged it into the probability app. Let me see here. So I put fail to reject the null hypothesis because the p-value was greater. But maybe someone should check me on that.
I'm double checking it right now.
I think every other answer is just redundant. We're not obviously not rejecting the. Well, it would only be A or B, which is reject A underscore A H underscore A, or it's failed to reject. So it's not 5% that the null hypothesis is true. And okay, I'm just saying I agree. Failed to reject.
Yeah, I'm good with B. Checks out for me.
Cool.
Right. 14.
I can go ahead and read that really quick. You would like to look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 for each group and test if those means are different. What is the correct statistical procedure?
Male students, females.
Would it be a paired sample t-test?
So this is, let's see.
Or wait, they're separate. Hold on.
It's either that or independent sample t-test.
Yeah, I think it's independent.
So yeah, I put D,
Yeah.
independent sample t-test, because it doesn't matter. They're not related groups. They're just random.
They
Males
don't
and females.
rely off of each other.
Right.
Sweet.
Okay, 15 and educate. Yeah, we're all good with 14, right?
Yes.
Yeah, I think
Okay.
so.
15
What?
an,
I don't like peanut butter.
an educator who is placing an academic achievement by males and females with similar academic support systems. She decides to use brothers and sisters in the same home. Furthermore, she decides to use only brother and sister pairs when they are next to each other in sibling order. Should they use a hypothesis test based on the independent or dependent sampling? It's dependent.
Dependent, right? Yeah.
But which
I would think the last one. Because if you select the brother, you have to select the sister.
Yep. I agree.
Cool.
Everybody good?
Yeah.
Yes.
16? Alright.
I'll go. A soil scientist collected random soil samples from the field and measured the dissolved organic carbon level for each sample. The researcher would like to conduct a 95% confidence interval for the mean dissolved organic carbon level in the field. Open the data file dissolved organic carbon. Use the information to answer questions 16 and 17.
Okay. So, asking us, so 16, I guess we can answer without doing anything to the data.
Yeah.
Of the 4 types of confidence intervals listed below, which one is appropriate? Well, it's one group, it's one sample, so it's not a mean of differences or difference of means. It's not C or D, I wouldn't think. And we don't know standard deviation, do we? It doesn't give it.
No, it doesn't.
So B would be logical for me, but I don't know what you guys think.
Yeah. Good for me.
Okay, so now we have to pull up that data file.
I sent you the link to it. But I hope it doesn't have to be done in SPSS. But
I guess we'll find out.
So I just pulled up the, oh geez, what's it called? It's just like the spreadsheet that has all of the.
yeah, I sent it to you. Can click on the link in the chat if you want.
Cool.
But you can do it either way.
I always like to use Excel, but.
Do you guys know how many questions the exam's going to be?
I have no idea. Probably close to what the review is, 30 maybe.
Oh, okay.
25 to 30. I don't know. I hope it's not more than that.
Yeah, seriously.
Then we have to do both homework assignments before.
Yeah. So I did this before, and I got D 11.168, 15.217. I plugged it into just plugged the data into the spreadsheet. I can't remember what it's called though. I'm gonna pull it up here.
Where is the data files that you can just pull up the data instead of having to use it on SPSS? Because the one that you posted there is just for
Yeah,
SPSS.
let me shoot you the link really quick here. There's always like a link in the reading, like in the lesson readings, but I need to just save that link because it's easy to get to. Let me see here.
I was distracted. What did we choose for 16?
Sorry, I'm just pulling it up here. We put, let's see.
Oh, sorry, my mic was muted. I put B. Believe everybody.
Yeah, 16 we put B.
16, confidence interval for Muse.
Are you talking about 17, Kelly?
No, 16.
17 is D delta. Is that's what you're saying?
Yeah, 17D.
So for 17, you got D.
Yes.
Okay, let's see.
Okay. Taking forever. All right. Okay, so did you guys find that link yet? Because I've got it. I can just send it.
Yeah, will you put it in the message? I'm
In
just
the
gonna
chat.
send it.
Yeah, I think I still have the chat up here.
Thank you.
Yep. Are we ready to go to 18, or do you guys want to plug in the numbers for 17 still?
I'm cool with just going with D. Because we have to do this exact same thing for 18 and 19, but for a different data file.
Why didn't the link come through on mine?
Yes.
I got it through Gmail.
The Google Hangouts chat?
Yeah, the one that's on. There should be a sidebar.
Yeah, there's a little sidebar you can just copy and paste it onto the group chat. You might have to, so if you have your mouse over like the screen, like in the middle, there's a little thing that pops up on the right, or I'm sorry, the left hand side. On the very top of that sidebar, there's a blue icon.
Chat box?
And that brings up the chat box.
So the Excel file we use to plug that in is called quantitative inference procedures. And let's see, I plugged it into a one sample t-test, I think. Got it there.
Okay. So, do we just want to go ahead and move on to 18 and 19 then?
Let's do it.
Okay. So it says a random sample of Hummers for sale in Los Angeles and New York were taken from listings at cars.com. We want to know if there is a difference in the listing prices between Hummers for sale in Los Angeles and the same for New York. Create a 95% confidence interval for the true mean. Open the file using Hummers, LA, and NY. So again, we have to open up that data file. So this is going to be the type of situation. Let's see, comfortable.
I put D. So you're comparing two means between two groups, and they're independent from one another.
Yeah, that makes sense. Solid.
Yeah. Independent.
And then, let's see. And then I just plugged it into if you open that spreadsheet, there's a tab for two sample t-test. Let's see here. Yeah, two sample t-tests. I just plugged in the numbers from both of those, variable 1, variable 2, and I got
That's what I want to teach.
C.
You're not gonna say that? Well, I will. I was gonna make. So I told Megan we should make dinner soon. She went to the gym, so I was gonna make some.
Let me know what you guys get if you're plugging it in.
You said for 19 you got C, right?
I got C, yeah.
Okay, that's almost what I got. Somewhat close.
Yeah, I just copied and pasted and threw them into the columns A and B on the two sample t-test tab of that spreadsheet or that document. Plugged it in there, but
My watch. I'm fine with C.
okay. Cool beans. All right.
Are we all good there?
Yeah, I can read 20 real quick. It says, many studies have suggested there's a link between exercise and healthy bones. Exercise stresses the bones and causes them to get stronger. A study examined the effect of jumping on the bone density of growing rats. There's 3 groups, a control group with no jumping, a low jump group, and a high jump group. After 8 weeks of 10 jumps per day, 5 days a week, the bone density was measured. The rats were selected at random for 3 groups. And they'd like to know if there's a difference in the mean levels of bone densities between the groups. Use a level of significance of 0.05. So this is an ANOVA test. So if you just throw that data into the ANOVA tab on that document, it will give you all the answers.
How do you know that that's an ANOVA test, though?
Because it's comparing more than 2 groups.
Oh, okay. So when you have more than 2 groups, it's always ANOVA.
Yeah, ANOVA analyzes it's an inference of means for more than 2 groups.
Oh, okay, yeah.
If it was just like a control group and a high jumping group, then we would do either a paired sample or an independent samples test.
Right. But yeah, out of the book it says ANOVA is used to compare the means for several groups.
Yeah, I think so.
Yeah, sweet. Okay, and then to calculate the test statistic, you have to pull that one up. Does someone have the link for just the data file instead of SPSS file on that?
I do not.
Exercise bone density.
I do not have that pulled up, but I can get to it.
I had it like bookmarked at one point, but I cannot find it.
I know.
Didn't I send it to you? Is the one I sent only open for SPSS or what?
Yeah, the one that you sent it's for SPSS, and
let me send you mine real quick.
Well, this will solve a problem we've had for a while.
I'm about to punch my Wi-Fi. It's being so slow. So when I plug it in, let's see what I got. Let's see. So the F statistic or the test statistic, I got C, and the p-value I got B, 0.002. But I'm just pulling up that.
Yeah, I can't.
That link.
Data files are.
Yeah, I'll send it to you. I've got it right here.
How do you where do you go in to find that?
So the links, if you go on to like the lessons that we read or like the test review,
Yeah.
there's like they have links there for it. It'll say open this link, and then it actually has the link on the page, and then it'll take you there. But I'll just send it in a link to you guys really quick or in the message.
Thanks, man.
Yep.
I got in cursive. Oh, look.
So you're talking about the link in the review. Okay, I see.
Okay, I'm sending it right now. Copy this. Send it over. Okay, so I just sent it over. See, I should probably just save that somewhere. It's annoying trying to find it.
Gosh, I think you just sent it in the. Oh, okay, you sent it here. Gotcha.
Sorry, like in the chat. I guess I could have sent it in the other one.
That's fine. Yeah, I can access it from here. Okay, here it is, the data file. Sweet. Okay. And then it's the.
So if you just plug those in, like on the ANOVA spreadsheet, there's columns for like 6 different variables or 6 groups. You just plug them into columns A, B, and C. It'll give you the test statistic, the the p-value, all that.
Oh, yeah, so you just run another test using SPSS.
Or I like to use the Excel version that I have, but.
Oh, there's an Excel version of ANOVA?
Yeah, he sent us the link earlier. You just have to go to the.
Yeah, so that first link I sent, it's got 3 different spreadsheets on it. If you click on the one that's called Quantitative Inference Procedures, it's got the spreadsheets for like a paired sample test, an independent sample test, ANOVA, and then I just save that on my computer and use that template for these problems.
Oh, yeah, I see that. 1 sample, paired sample, 2 sample, and ANOVA. There it is.
Yeah, dude, it's way easy. Just plug and
I
go.
had no idea that was available to us. That's awesome. I mean, I was just doing it on my own, like making all the formulas work, and that was a lot more work. So, okay, sweet. So for the test statistic, you got 7.9. You said the third one.
Yes. And p-values be 0.002.
Okay. Which makes sense because if you have a higher test statistic, you usually have a smaller p-value.
Yeah.
From what I remember. Problems before.
Josh just said his computer shut off and he's rebooting, so he got knocked off. Josh.
Oh shoot!
Bummer.
He sure is handy.
He sent me a text.
I'm impressed. He's better than we do, that's for sure.
Maybe send him another invite in a minute.
Yeah, just let me know when he texts back when his computer's booted up.
Should we jump to 23?
Yeah.
Which of the following best expresses the conclusion of this test? Use a significance level of 0.05.
So because it is smaller than 0.05,
you reject. You fail to reject that. Or no, you reject.
it always screws with me a little bit. But let's see. There's to conclude when that's same.
Smaller.
So it'd either be A or B, correct?
There's sufficient evidence.
Or okay.
I don't know this one.
Do you remember this, Jess? On like when you're trying to find out if there's sufficient evidence, is it when it's smaller than the level of significance that you reject or you fail to reject?
It's 1 second. It's right here.
I always
So if the p-value is less than it, then you reject it. If it's greater, then you fail to reject.
Okay, yeah. So you're right, Kelly. When the p-value is smaller, you reject, and when it's greater, you fail to reject.
But that's not what this is asking, right? I said that, but that was with the.
It's kind of the same idea, though. It's just saying sufficient evidence instead of rejecting or failing to reject the null hypothesis. So because it is smaller, we would say that there is sufficient evidence to conclude the one that both the groups is the same. So I'm guessing it's either the first or the second one, because it could be that just one of the groups is different.
How do you know which?
I'm not entirely sure, because I mean, when we did the ANOVA test, it's testing all the groups as like into one test.
You guys got along great?
Shoot.
Alright,
Alright, well, we can go on to number 24. We'll come back to that. Alright, so pressures of supply and demand act directly on the prices for an airline ticket. As the seats available on the plane begin to fill, airlines raise the price. If seats on a flight do not sell well, an airline I can skip over this. Data were collected on the cost of one-way ticket from London to over to a variety of destinations in Europe. The lowest published ticket price is Okay, quite 90 days in advance, and then again 14 days in advance. Perform my hypothesis test to determine if there is a difference in the cost of the non-flight flights when tickets are purchased 14 days in advance compared to 90 days in advance. Use the level of significance of 0.10. Then we have to open the data file, direct flight costs.
Okay, I'm back. Sorry about that.
It's totally fine. What computer are you using?
It's just like an Asus laptop, but it's dying on me slowly, so it just dies when it has like 40% battery left. It's stupid.
I feel you. I had an Acer before I got my MacBook.
Dude.
The thing that would always die on me.
Yeah, they're bad. So did you guys answer 23 yet?
We were thinking it's either A or B. But we can make a surefire decision.
Let's see, for 20...
So isn't it that because the p-value is smaller than level of significance that you would have sufficient evidence?
So because the p-value is less, you reject the null hypothesis, which was... So I put A, that there's sufficient evidence to conclude that the bone density of all three groups is about the same.
Okay.
Because the null hypothesis was that if they had the rats jump, that the bone densities would differ. The test hypothesis was that they would be the same.
Okay. So yeah, that's
Kind of my logic, but I don't know.
That's kind of how we were looking at it as well. We couldn't figure out if it was all three groups or if it was one.
Wait a second. I put actually. Oh wait, if the. Oh man, hang on. Actually, I might have put B. Were you guys thinking B as well as possible?
Yeah,
Between A and B.
Yeah, I ended up putting B. I was reading the wrong one. So the null. Let's see.
Yeah, it should be B because A is saying that the
Yeah, B.
same, but it's different. It's what we're trying to test.
Right. Yeah, I agree. I think it's B.
Sweet. All right, so for number 24, we're dealing with airline tickets, people that buy them 14 days in advance and then 90 days in advance. So we have two different samples. I'm guessing it's an independent sample test. But because I don't think they'd be dependent on each other. Well, actually, I guess they are because the faster the 90-day tickets sell out, then the more expensive the 14-day tickets become.
Right, like choosing the 90-day for the test, you have to choose the 14-day. It's like.
So it would be a dependent sample test then.
I think so.
Yeah. Okay, and then we just have to find the test statistic and then also the p-value, and then just the same thing as 23 on 27.
Okay. So.
Josh, could you share your screen and we could see what you do as you pull that data file up on
Yeah.
Excel?
How do I do that?
So go to the Google Hangout window.
Okay, one sec. Google Hangout window. Okay.
You're on it, and then you're gonna hover your mouse over it, and there's gonna be a little toolbar on the left-hand side that has like a green button that says Screen Share.
Screen share. So.
It's a little green screen.
You hit that green button.
And then it'll give you two options.
Hang on. So I'm on the Google Hangouts page where we have the chat going, right?
Yeah, where like you can see everybody.
Oh wait.
You click on the screen. There should be a left bar that opens.
Oh yeah. Okay. Screen share. Got it.
Yep, and then just hit share entire screen.
Share desktop, I think it calls it.
Okay. Sorry. Screen share. So I just click full screen and start screen share.
Yep.
Okay, can you guys see it?
It's black. Oh, there it goes. Yeah, we can see. Okay, go ahead.
Okay, so the data file we need is direct flight costs. Let me get back to that link. Okay, so you got to pull up direct flight costs right here.
Mm-hmm.
Open that one, and then while I'm doing that, let me get open the other one I had up. It's like that closed down, my computer shut off. Alright. Come on now. Sorry, it's being slow. Enable. Okay, and then I'm gonna enable this. Alright, so let's see. So this is a paired sample test with two variables. So I'll delete that data and input the data from this. So here's the 14 days, the 90-day data. So I'm just gonna run this down, copy it, and paste it over into variable 1. And then variable 2, paste that in. Oops. Let me try that again. Okay. So here's the tricky part, is the type of test between the two variables. So they're wanting to know if the 90-day is cheaper than the 14-day, so less than, right?
Yeah.
So I click on less than. And when I did this, it didn't give me the exact numbers I was looking for. If you look at the T, the test statistic 1.685, that is not an option. Oh yeah, it is right there. Duh. Oh yeah. So when I did it, it wasn't giving me the right answer. What the heck? And now it's doing it. Perfect. And then the p-value is right here, 0.952. Yeah, see the p-value it's not giving me.
Okay, well, go back to the Excel spreadsheet. Yeah. Isn't our confidence interval, is that 95?
Greater than? Is it greater than? Because that would give me 0.0478.
And that's not an option either.
That's not on there either. See, that's what I got hung up on earlier, was am I doing this the right way? But
do you maybe have to change the level of significance to 0.1?
oh yeah, where's that at?
So the confidence level is, I think it's still 95.
Yeah.
Yeah. Yeah, it's.
I just don't remember like doing the homework for paired samples. I don't remember having to do anything like. I just don't know why it's not giving me that.
Change the confidence to 0.90. Yeah.
And that changes the confidence interval, but not the p-value. So I don't know.
And then I guess I was going to ask you. So when I try to do that on my end, because I'm using a Mac, I can pull up the Excel sheet, everything like with all the different tests on it, but I can't pull up the data file that you're looking at right now because it downloads it, but it says like when I go to open it, like I have to open it up through SPSS. So how did you get it to open it up on Excel? Yeah.
You have Excel on your Mac?
Yeah, I do.
Oh, what the heck?
Yeah.
You mean when you go to this screen right here?
Yeah.
Like these files?
No, the other files were.
Oh, these.
The data files. Yeah.
Some of them, yeah, the XLSX.
Wait, can you go up a little bit? Sorry, just real quick.
Yeah, sure.
So it should say at the top. Keep going up. Okay, yeah. So those are Excel data files. Where did you find that?
You mean this is like when you're in, you mean this screen right here?
Yeah, how'd you get that page? Because I
So
couldn't find the SPSS data files.
yeah, so right here. Oh crap, where'd it go? So when you're in the reading, like in the lessons, or if you click on the review, like the review questions for this test, in the reading it'll say, use the Excel file direct flights, and then it will have this link in there. So when you click on it, it'll take you to this page. So
Okay.
I wish I had my BYU, my like iLearn up. I could show you, but
I can show you, see if it works on mine. I have that lesson review open.
oh, okay, yeah,
So let me share my screen and see if it works like you're saying.
yeah, sure.
Thanks for explaining that though, Josh.
Yeah, no worries.
Because like I've done.
I was confused earlier trying to do the p-value. I just don't know why it wasn't working for me. Maybe the quiz is wrong and we're right.
Yeah, a lot of times I feel like that's the case. Well,
Okay, so this is the homework here,
okay.
and you've got these links in it.
Oh, is it right there? Is it red? Yeah, I think but it could be
Where's the Hummer one?
that. You guys save the day.
Oh, here's one. Dissolve organic carbon for 15 through 26.
Uh-huh.
What happens when I click on it? So it opens up.
Yeah, and that's what mine does.
Yeah, so it's got the right files in it, right?
Okay, sweet.
Okay, so my problem is, so I clicked on that very link, and I'm going to screen share now. This is annoying as crap, but I'm going to share with you why I hate this. This is what it pulls up on mine. Can you see that?
Yeah, that's the SPSS because the
These are not Excel, and I clicked on the same link.
What in the really? So how about going through the chat that we have? Is that working for you?
Yeah, with these over here, these so copy this.
Still not pulling it up, huh?
Pulls up the same thing.
Oh my heck.
Hey, real quick, Jason, just go to the top of your screen where you pulled up the Excel data files, and then click the very top where it shows the.
Oh, I turn back on my screen share again. Let me turn.
You don't have to. Just go to the very top of your Excel data files, and then click the top where like where the what do you call it, the direction, the website URL.
It just says statistics.byuimath.com.
Click it. Go ahead and click it. It'll.
Let me grab it all and I'll share it with you.
Yeah. Just click that and then copy and paste. Okay, let me see if this works. See, yeah, mine still pulls it up as an SPSS using that same exact link you just sent. I need to.
Here's one thing back to the spreadsheet that you pasted your data into. If you change the type of test to not equal to, so the price does not equal the other price, that gives you a p-value of 0.096, and that is an option on number 26.
All right, let's go with that.
So maybe you don't have to fiddle around with which variable is greater than the other. It's just, are the prices equal or are they?
You turn the confidence interval back to the 0.95.
Yep, exactly.
What does that do to your test statistic? Still 1.65?
So when you change the confidence interval, it has. Oh, wait. Oops, sorry. So confidence interval of 0.95 and 0.9, it doesn't do anything to the test statistic or the p-value. Those remain constant. So I would be confident that it's 0.096, but.
Alright. And then for 27, if p-value is that means it's smaller than the 0.1.
So you would It would be D, right?
Wasn't it because of it's smaller? Wouldn't it be sufficient evidence instead of insufficient?
So what's the null hypothesis?
It is.
Yep.
They want to determine if there's a difference in the mean cost of an airline ticket purchase.
Yeah.
So if it's smaller, if it's greater than, you fail to reject the null. If it's less than, you reject the null. So you've rejected that there's a difference in the cost of tickets, right?
Yeah.
Some of these get confused. Let me see.
So wait, because it's smaller than the level of significance, we're saying that we're rejecting that there's a difference in the cost of tickets.
Right, you're rejecting the null hypothesis that there is a difference in the mean cost of an airline ticket. So it seems that there is a difference. So you would.
The second choice B, right?
Or.
So it'd be B. There is sufficient evidence to conclude that there is a difference in the cost.
Right, there you go. I had it flip-flopped. You're right.
Sweet.
What did you guys put for number 2?
The first choice.
The first?
Yeah.
Okay, yeah. Awesome.
90%.
Do you want to go through 3, 4 as well?
Let me see. I think I plugged him in. 3 I put B.
Yes.
Yeah.
4 I put D.
We put B as in Bravo.
B as in Bravo. Okay, so
Which one is appropriate?
You put D like Delta.
D like Delta. So you put confidence interval for you, and it is unknown.
Yeah. I don't know how confident we were on that one, but.
So what's determining? So when you select a male, does that determine how you select a female?
No.
Kind of that was my thinking, is if how they're just randomly, picking out people that are male and female. I don't know if they're dependent of one another.
Okay.
How they get chosen, but I don't know. We can go with B. I'm good with that.
I'm good with B because that makes more sense. That they're two separate.
Yeah.
I agree with D.
Are we saying Bravo?
4 is D.
D is a Delta.
Delta 4. Okay.
Delta
Force.
Delta Force. Cool. Are we good, brethren?
I think we're comfortable.
How do we do?
We got 96.
Wow.
A what?
96%.
Just admitting mine. Sweet.
I can't
Awesome
even see.
work.
13.
I'm gonna try and figure out what I'm doing wrong as far as the data files. Why I can't get it pulled up and then Excel instead of SPSS.
I'm gonna do the same because I'm having the same problem. Maybe we can.
Yeah.
If you figure it out, tell me. If I figure it out, I'll tell you.
Because the confusing thing to me is even the link that Jason posted, which is an Excel link. I click that and it pulls it up as an SPSS.
Yeah, I'm in the same boat.
Like, why would it do that?
I don't know why it pulls up for me and not for you. It's just what I'm grabbing.
Jason, are you on a Mac?
Yes.
What the heck?
So am I.
Let me try it again.
Make sure it's the page that you're on is an Excel page, not the SPSS.
Yeah, it's the one that ends in XLSX.
Yeah, that's those.
It's
right.
a very short. It's like it doesn't show the full page. It just has exactly what I gave to you. Yeah, it says the Excel.
All right, guys.
I can try clicking on one of the files and see what. And all it does is download it. So that's not going to help either. Well, have a good night.
I've got to bounce out of here, so we'll talk to you next week. Good luck on the test.
All right, you too. Thanks,
Hey,
guys.
we'll see you. Yep.